Alright. So, the lab we're going to talk about this week is the weak acid titration curve simulation. So we are essentially going to be doing what we just talked about, taking a weak acid, titrating it with a strong base, but we're doing it in a simulation form. Now, if we were doing lab on campus, we would probably have at least 2 different titration labs where you would do probably weak acid titration and then perhaps a weak base titration, or even maybe a strong acid, strong base titration. But usually we do at least 2 titration labs. Unfortunately, since we're not on campus, we are kind of limited in terms of what we can do here. So what we're going to do instead is a simulation. And let's go ahead and let's read through the lab here. It's fairly short, it's just 2 pages. And I will talk you through what we're going to be doing with this simulation here. So, in our overview, it says titrations are a staple of any chemistry course, and so while it is a shame that we won't be able to do this lab in person, we can still analyze the data. We use the curves to determine 2 things about the acid we're titrating, the concentration and the strength. For this simulation, we will assume the following was done in the lab. We're going to assume that 20 mils of the acid was acquired for each titration, and that the molarity of the sodium hydroxide used is 0.1 molar. So no matter what data set you're told to use, because it's going to be similar to previous ones where you're going to put in your T number and it's going to tell you use this data and someone else will use different data. Everyone is going to assume these 2 things. This is always going to be true. You're going to start with 20 mils of acid, and the sodium hydroxide is 0.1 molar. Yeah, thank you. I always forget. Those of you that are watching this on YouTube later, you saw my screen. Okay, but those of you that took the time to be here now, I would like you to see the screen. Okay, so here is the here's what I was just reading. I just read this part here. And by the way, this is available now on Blackboard. I put it up this morning. So I know it was not available until this morning, but it is available now. So, let's see here. It is going to be due the week after spring break, the 22nd. So at that point, we should be caught up with this whole weird labs being offset by 1 week. So the lab we talked about last week is due 15th. This lab will be due the 22nd. And then at that point, because we have that week off for spring break, it'll go back to being correct, where the lab that we talk about that week will be due the coming week instead of 2 weeks later. And it should have the correct due date in Blackboard. Since I set that up this morning, just let me know if it's wrong for some reason. It shouldn't be, unless I just lost my mind for a few minutes. Okay. So, like I said a minute ago, 20 mils of acid. Everyone's going to assume that. And the base has a concentration of 0.1 molar. Okay. So, our objectives. Your task for this lab include plot each set of data. Everyone's going to plot 2. So there's going to be 2 sets of data for each student. You're going to identify the equivalence point on the chart. It's not difficult to do if you know what you're looking for. Number 3, calculate the molarity of each acid. Also not terribly hard, but it does require some calculations. The calculations are not anything that we haven't done before. It's all the same stuff we've done before. It's just there'll be kind of a few calculations strung together to get the correct molarity. And then number 4, determine the pKa and Ka of each acid. Okay. And again, that's not too terribly difficult if you know what you're looking for, if you know what you're doing. It's not too bad. So, what to turn in? So, all three of these things need to be turned in to me, or you will not get full credit. I want both the titration curve charts, not the data, just the chart. I have had several students on previous labs, and obviously they weren't doing it maliciously or anything, but they would turn in the Excel file with, the whole 300 data points or something on the lab, and it just is a pain in the backside for me to grade that, because I have to essentially search for your data amongst all just the useless stuff. So don't turn in the data. You can either take a screenshot of the chart and turn that in, or you can move the chart to its own book and turn that in. There's a few different ways you can do it. Just don't turn in the data. You should turn in the molarity, pKa, and Ka of each acid you studied. So there should be one for each. Like I said, there's two different curves you're going to look at. We're assuming that each of those are different acids. So you should have different values for each of these three for those. And then show your calculations. If you just give me the numbers, I won't give you 0 credit, but you will not get full credit. To get full credit, I need to see the work you did. So if you want to type the work out, that's okay. If you want to have it written out and just either scan it or take a picture of it, that's also perfectly fine, as long as I can read it, as long as it's easily legible. Okay, so making your charts. Use the Excel spreadsheet provided to determine which 2 of the 8 sample sets you'll be using. For each titration, you will plot pH versus milliliters of sodium hydroxide added. You may just select the data columns as provided and make an XY scatter chart. So the data that is given to you is actually pH versus mils of sodium hydroxide. So this is the file that you're going to be using, and I've just inserted just some random T number. As far as I'm aware, that's not an actual student T number. So I noticed that usually the T numbers nowadays anyway start with a year, a recent year, or an upcoming year, and then I just picked 4 random numbers there, and it told me that I'm going to use number 4 and number 8. So this imaginary student would use this data for number 4 and this data with number 8. And notice that the data is already mils of sodium hydroxide and pH. And so to plot it, you should be able to just select both of the columns. So just click and drag on A and B, insert, scatter. There we go. So we have our data there. The 22nd. So this day. Okay. So that is the data plotted. And so you would just do the same thing for the other one as well. Okay, so then there's a few things that it wants you to do here. It says plot the data with smooth lines, no markers, and so we would actually change that because I plotted that without smooth lines. But that's fairly easy to change. If we go back here to chart design, I think that's where we would find what we want. Or is it format? Change chart type, that's what I want. Okay, so you would just have this done from the first thing, but so we want scatter with smooth lines is what it actually called for, which you can't really see the smooth line anywhere except for right here in the middle. because the data points are so close together. So we're going to label the axes. I've showed you how to do that before, so I'm not going to do that here again. Scale the axes to best show the data, cut out any wasted space. I think that's fairly well optimized there. You don't, like if it was, if the whole curve was just in this little corner here, let's say, okay, there's a lot of wasted space there. But that's not terrible. Like, the way it's done it there isn't bad. Add grid lines, such as it's easy to read the chart and confidently estimate the EP. That's the equivalence point, by the way. And so this has some grid lines, but it's not a bad idea to put more in there. Let's see, I believe we can do that in format plot area. Let's see. No, that's not right. Where do we put in our grid lines? It's been a while since I've done grid lines. Add chart elements. There they are, grid lines. So it's add chart element, grid lines, and we'll do some minor vertical grid lines. We don't really care all that much about the horizontal ones. At least I don't think we'll need horizontal ones. Although I guess it's not bad if you want to put horizontal ones in as well. Okay, and then make the chart look all spiffy and professional. So I will let you do that as best as you can. Okay, so here we have a sample titration curve for a weak acid. It says yours should have more grid lines added to make identification of the equivalence point easier. And so to find the equivalence point, all you're going to do is just take a look at your graph and estimate where the inflection point is in this big jump here. Now, the inflection point for the calculus fans in the group, and I know I talk about this in the videos as well, but I'll mention it here too. That is where that'll be the first derivative, goes from being positive to negative. So the first derivative is positive going through here because it is increasing, the slope is increasing, but then at some point right in the middle, the slope starts to decrease and it's increasing. Like it's still going up. The line is still going up, but it's not going up as fast. And so that means the first derivative has turned negative. And so that middle point right in the middle of the jump, that is the equivalence point, where your first derivative becomes negative. So that's your equivalence point, and more specifically, the volume is your equivalence point. Whatever volume you are at that point is the equivalence point. And the 1/2 equivalence point is just literally 1/2 of whatever that is. So if the equivalence point had been 40 here instead, which obviously it isn't, but just for the sake of easy math, if it had been 40, the 1/2 equivalence point would be 20. It is literally just 1/2 of whatever the EP was. And that equivalence point is equal to the pKa. So whatever the pH is at that 1/2 equivalence point. And so I guess in this case it might be easier to estimate that if you did have the horizontal grid lines. Whatever that pH is, that is the pKa of your acid. And so here it talks a bit about finding the equivalence point. I'm not going to read through that because it explains it pretty well. So just make sure that you read through that and that you do what it says. And so then here, talk about calculating the concentration of each acid. We're going to use this equation to do that. It is a very handy equation, and it is essentially just a modified version of the dilution equation. It's obviously not being used solely as a dilution equation, but it really is just kind of a modified use of the dilution equation. And so the Ma and Va are the molarity of the acid and the volume of the acid. Ma is what you're trying to find, the molarity of your acid. Va, as it mentions here, is always going to be 20. because we're assuming, that was our assumption at the beginning of the lab, that we started with 20 mils of acid. MB and VB are the exact same things, just for the base. So the molarity of the base we assumed was 0.1, and then VB is the volume at the equivalence point. So whatever you end up getting here, whatever volume that is at that equivalence point, that is the volume of base, VB. And so you'll just do a little bit of algebra and solve for MA. So then the last thing here is using that 1/2 equivalence point, which I already kind of described. Just using that 1/2 equivalence point to find pKa, and then you will have to do a little bit of algebra to find the Ka. You'll just do the anti-log to get rid of the P and find your Ka. And that is it. It's really not too intense of a lab. If you know what you're looking for, and you're feeling comfortable with the algebra, it's not too crazy. Are there any questions about the lab? Yeah, the equilibrium problem sheet, that is due the 15th, I believe. It's 15th, yeah. Any questions about the lab? No. Spring break is next week. You probably... see, your line is smooth all across and doesn't really look like mine. Does it have the same shape? Or is it just the line doesn't look the same? Okay, it could be... let me see. It could be that... let's see. I do scatter. Okay, yeah, so you did this one. I did... the way I did mine was slightly different actually than what the lab said. If you did it this way, I actually prefer it this way. But if you want to do it this way, that's fine too. So the scatter with smooth lines doesn't actually show you the data points. The scatter with smooth lines and markers, it is essentially, it's the same as the scatter with smooth lines, only it actually shows you the data points that it's putting in. Either one is fine by me. I'm not going to count off if you do it one way or the other. So this is probably what you had there. It's the same data. It's just not showing you the individual data points. Me personally, I didn't write this lab. I would have had you show the data points. But if you can do it either way. Either way is fine. The data points aren't so far apart that I'm worried. That the reason why I like to see the data points is because sometimes you will have students that make a graph, and instead of having a whole bunch of data points, and there's a little bit of a gap there, but that's not unusual at all near the equivalence point. They'll essentially be hiding the fact that they don't have very many data points by just not showing the data points at all. And so that's why I like to see the individual data points. But since I'm giving you this data, I'm not worried about that. So yeah, either way is fine. Okay, is the Is the equivalence point the only one that has to be smooth? I'm not entirely sure I understand the question. The only one that has to be smooth. Oh, okay, yeah. So the graphs, like I said, if you want to make it smooth, that's fine. If you want to show the data points and have the smooth line, that's great too. Either way. The date for the test is the week after spring break. So any time after spring break, it's probably going to be online again, like exam 1, most likely, unfortunately. I know you're not thinking that. You're thinking, woohoo! But for me, unfortunately, it's probably going to end up being online instead of on campus. I'm still hopeful that later exams, but I mean, they don't even want us to come back to campus at all. I'm still trying to get permission for my on-campus, for my blended classes to have lab after spring break, but I'm not hopeful about testing stuff just because they don't even want my labs on campus. But fall is, I have been told that it hasn't been decided, but I should be prepared to have it like this semester. So I should be prepared to do the fall like I'm doing spring right now, but that hasn't been 100% decided yet. I am really hoping to be able to have a normal class, like even if it's just one. I would like, just one normal class. By normal, I mean on campus, fully on campus class in the fall. To me, at least, it makes perfect sense to have an on-campus class, because even the most dire predictions that I've heard are that everyone that wants a vaccine should have a vaccine, by the end of May, I think was what they were saying now. And so, I mean, at that point, there's not really anything more we can do. So we might as well, at least in my mind. I don't make the decisions, but at least in my mind, at that point, there's nothing really more we can do, so we might as well go back to having on-campus classes. So, but I don't get to make those decisions, so we will see. We'll see what happens. Other questions? Nope. All right. Well, if there are no other questions, I think I will let you all go. You too, Chase. Have a great day. Try to watch the videos so that we can talk about solubility on Thursday. And enjoy the weather.